Hello everyone, welcome to Extramarks Smart Classes, a smart way of learning. I am Venus Jain, your physics mentor, and today we are going to discuss very important topic, motion in plane. So before starting motion in plane, we must go through basics that are vectors. Now this term might be new for you, but they are very easy. Now let's understand what vectors are. In the previous chapter, we have studied about the basic concepts of a number, let's say distance, right? Now, if there is a class and there are 10 people in the class, and if I ask you to stand and walk for 5 meters, right? So everyone will start walking for 5 meters in every random directions. But if I ask you to stand and walk for 5 meters in north direction, then each and every particle, each and every person in the class will walk in same direction, right? This is a basic difference between a scalar and vector. In the first case, I have given you just a number, 5 meter, that you have to travel a distance of 5 meter. But in the second case, when it is a vector quantity, I have given you distance along with the direction. Now, so here we are going to discuss two important properties of scalar and vectors. Now, scalar quantity means which has only magnitude. So, if I ask you 2 kg of rice, so rice is a quantity, and this 2 kg will tell you the amount, the magnitude. No one will ask in which direction 2 kg is, right? But if you are walking or if you are moving your vehicle, then you will say I am moving with a speed of 5 km per hour or 10 km per hour. And if you are adding the direction to it, that 5 km or 10 km per hour in north direction, south direction, northwest, or any random direction, if your final destination is known, then you are adding direction to the quantity. So it becomes a vector one. So the following examples of scalar are, as you can see on screen, it is mass, it is 1 ton, right? Metric ton, kg, milligram, gram. We have length, time. All these quantities are scalar quantities. Now, so scalar quantity is specified by its magnitude along with its unit. Always remember the unit is very, very important. Because if you go to a shopkeeper and if you ask, give me 1, what he will give, right? Or if you go to the shopkeeper and ask, give me rice, right? Give me 1 rice. So for defining any quantity, you must use a unit as well as its magnitude. So 2 kg rice is 2 is magnitude, a number. Kg will be its unit, and the rice represents a quantity. Now, here in the figure you can see there is a point A and B, and the distance between the point is 30 kilometers. So this is basically a scalar quantity because this is a distance. Here we are not giving any direction to it, and we are not concerned about the direction also. Now, for addition, subtraction, multiplication, division of scalar quantities, we need not to apply special rules or laws. What we have, if I ask you 2 plus 3, you will say 5. If I ask 9 plus 2, it will be 11, right? So, similarly, you can multiply, divide numbers easily the way you have learned in the previous basic classes. And why I am focusing over here, because it is somewhat different from what we are going to do in vectors. So, in order to add vectors, we have some different law that we will talk of later. Here I have given an example. Let's say I have given you a square of side length 1 meter each. Now, if I ask you to find the perimeter, perimeter means the sum of all the sides. Or you know the formula, the perimeter of a square is 4 times the length. So if I ask the perimeter of a square, then it will be L plus L plus L plus L, that will be 4L, that is 4 meter. So here you have to remember the length is also scalar quantity, perimeter is also scalar quantity. Now, then what vectors are? So the vector are the quantities which have magnitude and direction both. This is a very basic format of vector. So here there are some examples given of vectors, that is velocity, force, momentum, right? Now let me explain you in a more clearer way. So assume there is a body of mass m in my hand, right? And what I have to do, I have to make this body move. Now in order to make this body move, I am applying force on the body. Now think, do you think the body will move? Your answer? Maybe, right? So assume I am applying a force in this direction, perpendicular direction, right? In this case, do you think the body will move? No. But if I apply a force in the horizontal direction, then definitely the body will move. So you can never comment anything without knowing the direction if a quantity is a vector quantity. So if you are applying a force on a body, the body may move, the body may not move. It depends on the direction of force applied on it. That's why these types of quantity in which the direction play an important role, these types of quantities are called as vector quantities. Now I hope it is clear to you, right? Let's move on. Now very important part, how to represent vectors, how they are different from scalars, right? So always remember, the vector are represented by an arrow symbol, right? So this part is called as tip of arrow or tail of arrow. This is called as head of arrow. Here you can see A point is called as tail of arrow and B is the head of arrow. And the arrow symbol represents the direction and the length of the arrow represents the magnitude. Remember the magnitude I have told you before also, right? More the length, more will be its magnitude. And the arrow, the head, will tell you the direction. It is always represented by a vector. We never call it as a arrow, right? Always call it as a vector. It means whenever you find any alphabet with the arrow over it, it means that quantity has direction too, apart from the magnitude. So here I call it as a vector, and this I call it as modulus of vector. Here this modulus symbol means it will show me the magnitude only. It will give me only magnitude. That's it. Whenever I write mod a vector, means I am just talking of its length, of its magnitude. In that case, I forget about its direction. But when I say a vector, I will use the magnitude also as well as its direction also. Right? I hope everything is clear. Let's move on. Now, there are different types of vectors, and we'll discuss each of them in detail. So the first type of vector in front of us is zero vector. Now what the zero vector is? Zero vector means, as it is clear from its name, it has zero magnitude. Zero magnitude means zero length. So the length of the arrow will be zero. Now you will wonder if the length of the zero is, if the length of a vector is zero, then how will you represent in arrow format? So your doubt is correct. Basically, its magnitude is zero, that is its length is zero, and its direction is arbitrary. It means whatever the directions you want to assume, you can, because it is of no use, right? Zero, right? Next type of vector is equal vectors. Now, it is a very important thing. How? Equal vector means if the magnitude of both the vectors are same, as well as the direction too should be same. Because here you are equating a vector quantity, and a vector quantity consists of magnitude as well as direction. That's why when you are equating two vectors, you have to take care of their magnitude, that is their length, as well as you have to take care of their direction, that is arrowhead also, right? So here if I draw vector A and vector B, I assume the length to be same. So I can write the magnitudes of A is equals to magnitude of B and the directions too are same. That's why I can write A and B are equal vectors. But if I draw these two vectors, then maybe their direction is same, but they are unequal vectors. Okay. Now, collinear. As it is clear from its name only, co means same, linear means line. When all the vectors, irrespective of their magnitude, it means irrespective of their length, if they are in same direction, if they are pointing towards the same direction, all vectors are called as collinear vectors. Next is unequal vectors. You know that if I am equating vector quantity, I am equating its magnitude as well as direction. Now, if the vectors are unequal, then they have same magnitude, but they have different direction. So here I can see both C and D have same length, but they have different directions. That's why they are called as unequal vectors, right? They have equal magnitude and they do not have same direction. That's why the vectors are called as unequal vectors. Now, next type of vector is negative vector. Negative vector has same magnitude but opposite direction. This is the difference between unequal and opposite, right? Unequal has any random direction, but the opposite will be exactly at 180 degree only to each other. So I can write, if there are two vectors, vector B and this is vector C, if I assume both to be of same length, then I can write vector B is equals to minus of vector C, because both are exactly opposite to each other. Next type of vectors are co-initial vectors. Co-initial vector means, you know that co means same, initial means initial point. If the vector are having same initial point, then all the vectors are called as co-initial vectors. Here you can see all the vectors are originating from point O. That's why they are collinear vectors, co-initial vectors, right? Now, we have already discussed this collinear vectors. When they are parallel to each other, they are called as collinear. Collinear means they should be along same line, right? The very important vector is unit vector, and I can say it is the smartest vector. Why? Because it wears a cap. So I'll tell you what is the meaning of this cap. We represent a unit vector by A cap, B cap, C cap, like this. So why I am not show with arrow? Because it is somewhat different from a normal vector. Now, let's start what this vector has speciality in. So this unit vector is a vector whose magnitude is unity. Magnitude is unity means the length of the vector is 1 and the direction is exactly equal to the original vector, right? Or I can say, in other words, it has no specific direction, right? It always takes the direction of the original vector from where I have taken the unit vector of. So you know that this is called as A vector and this is called as modulus of A vector. Then this modulus will give me length and A vector will give me length along with the direction. Now if I divide these two quantities, I'll get a quantity called as unit vector A cap. This is called as unit vector A cap, right? And it is given by A divided by magnitude of A. These types of vectors are used to specify the direction only. Why? Because what is the magnitude of unit vector? It is 1. Do you think if I multiply any quantity with 1, it will change? It will remain same. That's why these unit vectors are used to represent the direction or to make a scalar quantity a vector 1. How? I'll tell you. Now, first of all, you have to assume certain things, that we have 3 axes, x-axis, y-axis and z-axis. So as you can see on this board, this point is called as origin point, starting point. So towards right of it, I have considered x-axis, above it y-axis, and the third axis which is coming out of the plane, this is called as z-axis. Now I have defined unit vectors along all the three directions. So along x direction I am representing I cap, along y it is j cap, and along z it is k cap. Remember, I cap is the unit vector along x direction, j cap is the unit vector along y direction, and k cap is the unit vector along z direction. And you know that unit vector has magnitude 1. So I can multiply it to any number, the magnitude of that number will remain same, but it will just add up the direction. Now I'll explain you how. For example, I have taken this point to be origin 0, 0. I am marking this point to be 1, 2, 3. I am naming it as A, B, C. Now, if I ask you what is the length of OA vector, OA, then length of OA is nothing, it is 1 unit. If I ask you the length of OB, the length of OB will be 2 unit. The length of AC will be 2 unit. The length of CO will be 3 unit, right? But if I ask you to represent OA in vector form, OA vector means I am representing the position of A with respect to O. Here you can see we are going towards right, and it is by default we have taken convention that everything right to it we assume positive, left assume negative, above assume positive, below assume negative. If it is coming out of the plane we assume it positive, it is going inside the plane we assume it negative. These are our standard sign conventions. Now if I want to represent OA vector, means I am going towards right because I am starting from O to A. So whatever the length is, it is towards positive direction. And you know that if I multiply with a unit vector, if I multiply with a 1, then it will just add up the direction along x-axis. So can I write this as it is 1 I cap? So whenever any person will say you it is 1 I cap, means the first thing that will come into your mind that the length between those 2 points is 1. And the direction is towards positive direction, means the initial position is towards left and the final point is towards right. Okay. Similarly, if I write OB vector I can write it as 2 I cap. Now you can say that if it is a OB vector, means your starting point is O, ending point is B, and you are moving towards right of it. So from O to B, you can write the magnitude is 2, and the direction is towards plus I cap. So I can write 2 I cap. Similarly, tell me what should I write AC? Very good. It is 2 I cap again. Now think and say what is the value of CO vector? Remember your initial point is C, final point is O. You are going towards left of it. You are going towards negative direction, and when you are going towards negative direction, it should show in the vectors also. Here I have written 3 in the minus I cap direction, or I can write minus 3 I cap. So I write minus 3 I cap. It is easily understandable for everyone that you are moving for 3 units in negative direction or towards left, right? Now, a very important concept is the concept of resolution of vectors. Now what this resolution of vector is? You might have a knowledge of basic trigonometry. So here I am discussing that only. Let's say this is a right angle triangle and this is angle theta. Let's say this is the longest side, hypotenuse. This is perpendicular. This is base. Always remember, this is hypotenuse. Longest side is hypotenuse. The side which is opposite to the angle, it is called as perpendicular. And the side which is adjacent to the angle is called as base. Now, if I draw the same triangle over here, and if I consider this to be theta, then this will be h. The side which is opposite to theta will be perpendicular, and this will be base. Now, Can you tell me what is the value of sine theta? Sine theta is nothing, it is perpendicular by hypotenuse. Similarly, cos theta is nothing, it is base by hypotenuse, right? Now, what I am doing, I am doing a slight modification in it. I am writing this as h sine theta equals to P and h cos theta equal to B. Are you getting my point? It means whenever I give any right angle triangle and I have given this theta, let's say this distance will be z. So always remember the side which is close to theta is base. And how can we write this base as h cos theta? It means the component which is close to theta will be always h cos theta, and the component which is perpendicular to it or opposite to it will be h sin theta. So here I can write this is z cos theta, and that will be z. This component I can write this as z cos theta, and this I can write this as z sin theta. Okay. Similarly, if I give this angle, this TVP, this to be theta, then this I can write P cos theta, P sin theta. Always remember the side which is close to theta will be always cos component of it, right? Now, there are certain properties of vector quantities that you have to understand. If I draw a vector A, I can translate this vector along its line anywhere, and I can shift this vector parallelly anywhere. Please remember this point. I can translate the vector. Translate means move in a straight line. I can translate the vector anywhere, wherever. If I want it here, I can place. If I want somewhere else, I can move this, right? The vector will remain same. It will never change. Never rotate it, right? What you have to do, just translate, just move along its line, or you can shift parallelly also, anywhere. If you are shifting parallelly anywhere, the vector will remain same. Now, if we are multiplying a vector by a real number, multiplication of a vector by real number, if I am multiplying any vector by a real number means you can say any number, let's say 1, 2, 5, 6, 10, 20, all numbers are real numbers. Now, if I multiply 5 to 2, you'll get 10. The magnitude is changing, right? That's what happens when we multiply any real number with a vector quantity. So here in this case, you can assume, let's say there is a vector A which has this much length, and there is a real number C. When I multiply the C, a number, to a vector, you can see it becomes CA, right? Means C and A vector, C times A vector. So when you multiply any vector with a constant C, the length of the vector changes, means the magnitude of the vector changes, but the direction remains same. So here I can write this as CA vector can be written as CA. Only the magnitude becomes same C times, the magnitude enhances or decreases depends on the value of C. And if I multiply with minus C, then what it will do, it will exactly change the direction of the vector by an angle of 180 degree. Because you know that there are opposite vectors. Opposite vector means the vectors which are same in length but opposite direction, because they are having minus sign with them. So it will show that both the vectors are at an angle of 180 degree to each other. Okay guys, that's all for this class. We'll continue our rest portion in the next. Thank you.